Do you have experience riding a train? Well, good for you if you have. And if you don't, well, we can always imagine. Suppose this is your first time riding a train, and you want to explore the whole thing for the sake of experience. You start from the engine room. From there, you will go to the next train car that is connected to the engine room. There, you will see various boxes and containers where people's belongings are stored. After exploring there, you will then proceed to the next train car where you will meet a lot of people. And after talking to everyone, you will go to the next train car where you will meet more people. It's been a really fun day for you. Plus, you got to socialize with a lot of people. And you can't wait to see what's inside the last train car. You go in there full of excitement. But alas, you see nothing. The last train car is quite empty. Well, that's a bummer. Now, linked lists are very much like a train. By definition, a linked list is a data structure that is made up of nodes that are connected to each other. Each linked list starts with a head. In a train, you can imagine the engine room as the head of the linked list and the nodes as the train cars. Notice that each car contains different objects like boxes and people. If you're related to a node, these objects are what we call data, and the doors at the end of each car are the addresses for the next or previous nodes. Do you see those cables that connect each train car? Well, in a linked list, we call them pointers. These pointers always point to the next or previous item in a linked list. Notice that when you got to the last train car, there was nothing there. Now, take note that by the end of each linked list, the last pointer always points to a null value. Null simply means nothing. This is why the last train car is completely empty. It shows that it is the end of the train. Now, there are different types of linked lists. The first one is the singly linked list, or the SLL. Let's take a look as to how this works in our train. Let's say this is you, and right now you are in the engine room. You are currently accessing the entry point of the linked list, which is the head. You then go ahead and access the next node, which is the next train car. However, let's say you forgot something and you wanted to go back. But apparently, the door to the previous train car is locked, so you can't go back. Your only choice is to move forward until you get to the end of the train. In a singly linked list, you can only move forward. This is the actual visual representation of what an SLL looks like. Here's the head, and for each node, you have the data and the address for the next node. These arrows, just like the cables of the trains, are the pointers. Always remember that singly linked lists are one way, and you can never go back. Another type of a linked list is the doubly linked list, or DLL for short. In our train, just like what we did with SLL, we move forward. Suppose that you forgot something again, but this time around, the door isn't locked anymore, and you were able to go back to the previous train car and get the thing that you forgot. That's right. In a doubly linked list, you are allowed to go back to the previous node. You can either move backward or forward. This is the visual representation of what a DLL looks like. Again, you have the head and the nodes. But notice that you have another set of arrows that are pointing on the opposite direction. These arrows are the pointers that allow you to go back to the previous node. But take note, the pointer to the previous item of the very first node points back to a null value. Unlike singly linked lists, DLLs are two-way, where you can go either backward or forward. The last type of a linked list is what we call the circular linked list. Although it's not realistic, we can picture it out using our train, like this. As you can see, the last train car is connected to the first train car. In a circular linked list, the last element is linked to the first element, which will form a circular loop, thus getting its name. We can perform various operations in a linked list. Say you want to make your own linked list using a train. At first, we are going to need a head. Well, we know that this is the engine room. Now let's add a train car full of people. This represents a node, and the value is the people inside. Remember that the last element always points to a null object. That's why we are going to add an empty train car next to it. You want to add a train car where you will put your belongings. To do this, we're just going to put your belongings here in the empty train car, and we're going to add another train car that is empty. Suppose that you want to add another train car and you want to insert it in the middle. To do this, we're going to remove the link between the two and add another links to the car that you wanted to add. What we just did is the insert operation for a linked list. You can insert elements at the beginning, middle, or at the end. It's your choice. We also have the count operation, where it tells you how many elements you have in a list. Well, right now we have 3. Now let's say you have changed your mind. You now want to remove the car you just added. Fortunately, we have the delete operation. Now we are going to remove the links for this car, then relink these two. Ta-da! But let's say you change your mind again, and you don't like the train you just created and wanted it gone. And just like hitting a T minus button, the delete list operation does that for you.
Now, whatever you do, don't push this button, because that will set off the bomb immediately and we'll all be dead. Now, repeat back what I just said.
I am Groot.
Uh-huh.
I am Groot.
That's right.
I am Groot.
And boom, it's gone. In summary, a linked list is a data structure that is made up of nodes that are connected to each other. It has 3 types. Singly linked list, where each node contains data and a pointer to the next node. You can only move forward. Doubly linked list, where each node contains data and pointers to the next and previous nodes. You can move either forward or backward. And lastly, circular linked list, where the first and last elements are linked to each other, meaning the last item contains the link of the first element as next, and the first element has a link to the last element as previous. There are various operations for a linked list: insert, delete, delete list, and count, to name some of them.